Okay, this is section 3.4 video number 2 on how do you solve systems of equations with three unknowns. In the last video we looked at a system of three equations, three unknowns. We looked at what that looked like. We followed a step-by-step process in order to solve that system of three equations, three unknowns, and we came up with an ordered triple solution. In this video we're going to extend that and look at a couple special cases, and then also look at a word problem that turns into a system of three equations and three unknowns. Okay, so let's look at these two examples here. Call this example 1 and example 2. Alright, so looking at this first example, we've got three equations, three unknowns. We need to solve that system of equations. So we need to pick two equations and eliminate a variable. So we could start this several different ways. Looking at this, the easiest way would be maybe to take this equation, equation 1, and multiply it by -2 so that I can eliminate two variables at once. So let's see what happens if I take -2 times equation 1. I'll get -2x minus 2y plus 2z equals -4. Then I leave this equation as is. Add those together, and actually what happens is all three of the variables are eliminated. So I have nothing left on the left side and 2 on the right side. So if you remember when we were solving two equations, two unknowns, that meant that we had no solution. And it still does. Okay, so if you're solving a system of three equations and three unknowns, you work through and you end up getting a situation like this, where you have your variables are eliminated and you get two numbers that are not equal. It's no solution. Let's look at number 2 here. Okay, so on this one, initially what I see here is I have opposites already. So maybe I should add the opposites. Let me number my equations and add those directly immediately. So I get 2x plus 2y equals 6. Okay, so now if I'm following my steps, I need to use equation 3 and eliminate z's. So I could take equation 2 and 3 and add them together directly and eliminate z's. So let's do that. So I get 3x, 3y equals 9. Okay, so now I have my two equations that I combine and solve that system. So I could take this one, and it looks like we can multiply it by 3 and get multiply this one by -2, so I have -6x, -18, and look what happens here. Our variables are eliminated, so we get 0 equals 0. So just like with two equations, two unknowns, that indicated that we had infinitely many solutions. It still does. So those are our two special cases, so it's very similar to what we had before. Let's look at a word problem now. I'll pull this out of my book. We'll read through that there on the top right. So maybe just a little bit. We're looking at extra example 4 there. At a carry-out pizza restaurant, an order of 3 slices of pizza, 4 breadsticks, and 2 juice drinks cost $13.35. 5 slices of pizza, 2 breadsticks, 3 juice drinks is $19.50. 4 breadsticks, juice drink cost 30 cents more than a slice of pizza. What is the cost of each item? Okay, so take a minute, see if you can come up with your 3 equations, 3 unknowns, and then we'll write it down. Okay, so our first equation, we have 3 slices of pizza plus 4 breadsticks plus 2 juice boxes costs $13.35. 5 slices of pizza, 2 breadsticks, 3 juice boxes cost $19.50. And then the last equation might have been the most difficult one to come up with. They said 4 breadsticks plus a juice box is 30 cents more than a slice of pizza. So what I could set that equal to would be 30 cents plus a slice of pizza. So that's my system of 3 equations, 3 unknowns. Now we got to put these in standard form. So this bottom equation, we need to rearrange it and get the p on the other side. So I could simply just subtract p from both sides, and then I just have this. Just bring that over to the other side, save me some time. I'll just bring that over. Okay, so that's your system of 3 equations, 3 unknowns. Now we go ahead and solve that. So let's see. So maybe I take the first equation and the third equation. I have a plus 4b on both. So I'm going to rewrite the first equation. And I'm going to take the third equation and multiply it by -1. -1 times 3. So that's going to be p minus 4. Oops, I'm writing p minus 4b minus j equals -0.3. So I'll get rid of the b's, so I get 4p plus j equals 13.05. Okay. Now I need to take one of the equations I didn't use, so the second one, and eliminate the b's. Okay, so I could do that by taking the top 2. So let's take equation 1. And multiply equation 2 by -2. So then I get -10. So 1950 times -2 would be -39. Let's see, so I get -7p minus 4j equals, let's see, -25.65. So now I have my 2 equations with the p and the j, and I can do elimination. So it looks like I could take this equation and multiply it by 4. I'm going to save some time and just write it right here. So 16p times 4, so you get 16p minus 4j equals 4 times 1305 would be 5420. Okay, so now we add those together and I get 9p equals 2655. Divide by 9. And I get 295. So that tells me that a slice of pizza is $2.95. And now I work my way backwards and substitute. Okay, so let's substitute the $2.95 in for the p in any of these equations. So let's use this one here. 4 times $2.95 plus j equals 13.05. So that's 11.8. So subtract that. So looks like I get $1.25 for the juice box. Whoops. And now I substitute them both back in to one of the original equations. So let's just use the top one to make it easy. 3 times p plus 4b plus 2 times $1.25 equals $13.35. Okay, so 885 plus 4b plus 250 So what do I get there? So that's going to give me 3. So B equals 0.75. So it looks like it's 75 cents for the breadsticks. So that's my solution. Pizza's $2.95, juice box $1.25, breadsticks 75 cents.